So we are going to study about work, power, energy today. So first we will discuss about work. First work, power, energy we will study. Work, power, energy, right? Acha, in work, power, energy, first and foremost thing we will study about the work and what is work by. Let's see what is work. Work means F dot S. We can even write like this, Fs cos theta. We can write Fs cos theta. Same like that, if I have taken a particle, small particle I have taken, and I have given some force in this. Like I am taking force like this, F force, which is constant, F force which is constant, right? And S displacement is there with some angle theta. I have given this thing, right? So now if I draw a perpendicular line from here, it's a perpendicular line I have taken here. So if I break the component of S, so this will become S cos theta, and this will become S sin theta, right? S cos theta and S sin theta. So now if you see very properly, along the force constant, it should work done will be there. So we can write work done equals to F constant is there, so F S cos theta we can write, right? Same instant if I am taking here, so here what happens, see, like if I have taken like this something, I'm taking it little bit this side, like this I am taking here, right? So when we are taking this, same concept I am taking again, so that it will be clear. F I am applying like this force, F Newton force, and S is applied like this. Angle is theta. So now if you see very properly, now if I break the component of F, so here it will become in the direction, here what will happen, F cos theta in the direction y, unit vector of S, and again same thing, I am drawing a perpendicular line from here, I am drawing a perpendicular line from here, so this will become F sin theta, it is having null vector like this. So now if you see very properly, here, so what we are getting here, let's see, like if I am taking F, so what we will write here now, see, F cos theta S unit vector plus F sin theta null vector n vector dot S, this we will write. Acha, when we are writing this, so what we can write now, see here, F, this will become what, see here, F cos theta into S, right? And here it will become what, 0. So at the net which what we are getting, F cos theta S. So we can write work done in these many ways. Right? This is a talk of the work done. So we can write work done like this way. Achha, little bit more we will talk about this work done. Let's see. Little bit more we will talk about the work done. What we studied now? We studied that work done is equals to F dot S. Achha, what is this F here? By? F is the force, constant force applied. F is what? force, right? And S is what? S is what here? S is the displacement of the point of application of the force. I am writing it here. Displacement of point of application of force. Application of force, displacement of the point of application of the force. Why I said this thing? Like if I am taking an example, I have taken one rod like this, I am holding a rod and I am moving, right? I am holding a rod and I am moving. I will show that example in front of you, then it will be more clear for you. Like I am taking one rod here, like this I have taken the rod, right? One more I will draw it. Rod I have taken, right? And here someone, like I am holding it with some, right? And here it is, the person is there and that person is holding it, right? Here the person is holding it. It is moving, right? Holding it. And here F is applied. Here F is applied, bhai. Here F force is applied, like F force I am taking F naught. And this F naught is what? This point is what? This is what? Point of application. This can be said what? This can be said as, this is what? Point of application. Point of application, right? And if I consider here that the body or the rod, I am holding it like this and I am moving, so I have moved from here to here like x naught. So work done we will say here, that work done is equal to F naught x. Work done is equals to F naught x we will say, bhai. Thik bhai, F naught x we are saying. But in the condition, one situation I am just creating in front of you, like I am moving and the rod started falling like this. Are you able to understand? Rod started falling like this. When the rod started falling like this, I am making it like this. It was starting, initially it was like this, and after that it became like this. Like, 1 minute. Check, I'll draw it, that is better, no? Like it fallen like this. Rod is fallen like this, right? So from here to here when it is moving, so like it has moved x naught from here to here, but from here to here displacement is there. Here it is like it is given something like this, right? Yellow color I am taking. Okay. So like here F naught is acting here. Here F naught is acting. F naught is acting, bhai. F naught is acting. Here I am taking S naught. So now in this condition, what will be the work done, bhai? In this condition, work done will be F naught into F naught dot S naught. It will not be X naught. It will be F naught dot X naught. So what exactly we got? The direction force, which force? Point of application is moving, that displacement we are taking. So little bit more we will talk about the constant force. Let's see after this it will be more clear for you. Like constant force I am taking. Any constant force I am taking, right? Constant force means like F equals to, I have taken x I cap plus y j cap plus z k cap. Like this I have taken the constant force. Thick, or like fz, that will be more good. If I take like this, if I am taking like f in the form of f, I will take like fx I cap, it will be more clear, fy j cap plus fz k cap I have taken. Like force I have taken this one, and it is a constant force. It is a constant force, mere bhai. It is a constant force. Constant force, right? And here I am considering that one particle is there which is moving from, it is moving from like point A to point B. Point A to point B. Here it is having x1, y1 and z1. Here it is having some x2, y2 and z2, right? It is moving from here to here, A to B. It is moving from A to B. So when it is moving from A to B, the position vector R, what will happen? If I talk about the position vector R, so R we can write like this. Position vector R will be like x2 minus x1, we will write x2 minus x1 I cap, right, plus y2 minus y1 j cap plus z2 minus z1 k cap. We can write like this, right? So now if I will ask the work done, the work done will be equals to F dot R. F dot R. Acha, now see here, F dot R when we are doing, so I cap 1, I cap j cap 0. See, so now see here what we will do now here. So we can write directly like this, right? Fx x2 minus x1 plus fy y2 minus y1 plus fz z2 minus z1. See, if we got work done, so and position vector, directly we can apply this formula. Directly we can apply this formula, bachcho. ठीक, तो work done we can write like this. But one small talk is there, like one small thing we will see, like I have taken one body, like I'm taken one body here, I'm making a line first at some range. Here the body is there, है ना, like mass m, it is having mass m, mass is m, right, and it is falling like this. I am taking from here to here. Just a minute. Okay, and I have taken one curvilinear path, like this, a curvilinear path I have taken, and body is released from there, like it is having some height h. From here to here height is what? H. This particle I have taken here and I kept it here. So when I kept the particle here, like this mass m, mass I have kept here, like point A, and it will slide down and it will come here and it will stay, like point B I am taking, right? So now if I will say for the at the instant we will talk, so when the particle is here, let's see, when the particle is here, at some moment I am taking, when the particle is here, so we are seeing some of the things, like first thing, normal is acting like this, right? Normal is acting like this. Taking with different colors so that it will be more clear for you. Displacement is where? ds is in this direction. mg is acting down. mg is acting where? mg is acting down. So now if I will say, if I'll ask that what is the work done? What is the work done? Work done by normal. Work done by normal, when we are asking, to work done by normal means what will happen? Integration of f is what here? F is what here? Normal. F is what here? Normal. So f n I am writing, or n I am writing. N also we can write. N f is what? Normal n dot ds. N dot ds. Better to take it here s only, or small angle I am taking here ds. Let it be ds, right? ds. Achha, angle between them is what, bhai? Angle between them is what? If you see very properly, this angle is 90 degree. So here what will be coming now here? See, cos pi by 2, which value is what? 0. But one more force is there. What is that force? mg. mg is there. The work done by mg will be equals to, what will happen now here? See, mg is the force, and displacement by that is what? Displacement by that is what? mgh, and it is positive. Means net work done is what? mgh. So what we got to know from this concept? We got to know that here normal is perpendicular to the displacement, means angle became 90. Means here work done because of the normal or because of the tension will always become 0. Same condition will happen with the pendulum also. Like here pendulum is there, here pendulum is there. If I ask you what is the tension, what is the tension, work done by the tension? So work done by the tension will become what here? Work done by the tension will become what here? Work done by tension will become 0. Means work done by normal and work done by tension will become completely 0. Right? Acha bhai. I expect till here everyone is clear bhai. Thik? Acha. Let's see now. Next thing. Next most important thing is there, that is said as work energy theorem. That is said as what? Work energy theorem. I will be showing you in a two different method. Work energy theorem. Sorry, work energy theorem I will be showing you. So we will see the work energy theorem in a very easiest way first. Two method I will be showing you in this. Take like this I have taken, and one mass is there. One mass is there. The color I am changing to yellow, right? Another one more mass is there here. Its color also I am changing to yellow, right? Mass is there, and in this I have applied constant force like F. Constant force I have applied F. Take. Initially I have given that it is having some velocity v1. Initially, like f naught I am taking. Initially it is having some velocity v1. Finally it has got some velocity v2. Right? Same way, constant force is applied. F naught is there, and from here to here I am taking. It has traveled some s. Right? So now see how beautifully it will be done. Like work. Achha, one more thing, work done, if I will see, before coming to the work done, if you see here, velocity is changing. Velocity is changing, it means what, mere bhai? Velocity is changing, it means what, bhai? Acceleration. Acceleration equals to what will be there? F naught by m. F naught by m. Here F naught is also constant, m is also constant. So acceleration will become what? Constant. Acceleration will become what? Constant. When acceleration became constant, so we know that v square equals to u square plus 2as is applied when acceleration is constant. So now you will see that initially velocity is v1, finally velocity is v2. So we can apply like this: the v2 square minus v1 square is equals to 2as. Achha, what is the a? What is the a here, mere bhai? The a is equals to, we can write v2 square minus v1 square equals to 2 into f naught by m into s. Take. See now, f naught into s equals to what you are getting? F naught into s, what you are getting? See here, v naught, v2 square minus v1 square m by 2. M by 2. This we got the f naught dot s. The same like that, if I write the work done now, see here, if I am writing the work done, so work done will be what, say bhai? Work done will become what now, see? Work done is f naught s. Work done is what? F naught s. Actually, work done is f naught s. What is the value of f naught s you have got? F naught s is m v2 square minus v1 square upon 2. So we can write like this, see, half m v2 square minus half m v1 square. Acha, half m v square is what? Kinetic energy. What is that? Kinetic energy. So we can write here that work done is equals to change in kinetic energy means K final minus K initial. This is the simplest form. See here, work energy, work done. But one more but we are talking about the net work done here. Net work done here. This is the method 1 I am showing you. Method 1. One more method I want to show. If anyone is having query, you can ask me. So method 1. Acha, one more method I am taking. Like I have taken one path. Like any curvilinear path I have taken like this. Right? I have taken that curvilinear path, and here I have taken, like here velocity I am taking v1, and here velocity I have taken v2. It is a curvilinear path, it's not a straight path. So, so every time direction is changing. Stick by. When every time direction is changing, that some like particle is here, a small mass particle is here, right? Color I am keeping it in this, like blue, right? Small mass I have taken, and that small mass is moving along this path. Small mass is moving along this path. When the small mass is moving along this path, so how we will take this path view by? We will take a radius of curvature here. We will take one radius of curvature. Radius of curvature of this path. Radius of curvature of this path. Right? When we are taking the radius of curvature of this path, radius of curvature means R C I am taking, right? Acha, now particle is moving along this. When the particle is moving along this, the velocity of the particle is in this direction v. Velocity of the particle in this direction v. Thik? Acha. Acceleration, if we will talk, the acceleration towards the center, like acceleration an I am writing, an equals to what will happen? v square by r c, and here at is there. at equals to what will happen? dv upon dt. We can write dv upon dt by. Okay, dv upon dt, at equals to dv upon dt we are writing. As a displacement also, s also, s is where? In this direction s is there by. S is in this direction by. Right? Like this I have taken a situation in front of you. Take. When we have taken the situation, so we are talking only for this particle, small particle here. So I will draw it here again. I will draw this again here, so that it will be more clear for you. Right? I am taking this point here. This is v1 and this point is v2. Right? And here that particle is there. Which color I have taken there? Okay. Like this I have taken the particle. Take. On this particle I am taking that many forces are acting, like here F1 is acting, here F2 is acting, here F3 is acting, many forces are acting mere bhai. So till Fn it is going, here also forces are acting, many forces are acting on this, till Fn the forces are acting on this. Thik? Acha, work done said us what? Work done said us that F dot ds, like if I am writing it, I will change the page here. So work done said what? Net work done, if I will write, if I will talk about the net work done, so net work done will be what? For the small particle d net work done I am taking. So d net work done, what we will write here, see now, F1 plus F2 plus F3 plus so on till fn dot s. This only we will write मेरे भाई, this only we will write, ठीक ना. When we are writing this, so fs f1 to all the forces I have taken. Acha, now if you see in the last point what we have taken, if we talk about the net acceleration, if I talk about the net acceleration here, the net acceleration means A total. If I am writing A total here, see here, A total if I will write here, A total what will be the bhai? A total AT plus AN. And this only will be the A total na bhai? AT plus AN. ठीक भाई. अच्छा, here this is talking about F net. This is talking about F net. F net equals to what will happen? F net equals to M into A total. M into A total. F equals to M into A total we are writing. Achha, now if you see very properly, in the last scene only we can see here, AN is perpendicular to S, means angle between them is what? 90, and AT is along S, angle between them is what? 0. So we can write it here like this. See, so we can write, say, see here, AN and AS, sorry, AN and S, AN, S and S is having angle 90, and AT and S is having angle 0, right? Getting my point? Having angle 0. So now if I say what is the work done here? Work done, D work net, D net work. ठीक, तो D net work if I will write, so D net work we can write M into A total. See here, M into A total. ठीक ना, M into A total. This is what? Force. This is saying about what? Force, right? It is saying about the force. F into S. So S we have taken what? Displacement. The small displacement taking place here, right? F is the displacement is taking what here? ds, a small displacement we are taking here, right? Acha, now if I write here, see, M into M to A total is what? AT plus AN, AT plus AN dot ds, AT plus AN dot ds we can write like this. So here what will happen now? See, AT S dot S plus M into AN dot S. So now if you see very properly, this part I am taking in a bracket, this part became 0. This part became what? 0. We can identify it from here. Angle became 90, right? So what we are getting work done by? Work done net what we are getting? We are getting M dot, ds is there, sorry, here small mistake happened, here ds is there, right? M A T ds. What we have got? M A T ds. Achha, AT what we know? I'm showing it here. AT what we can write now? See here, AT what we can write like this. I'm taking it side. So here D net work done is equal to M into AT. AT was what? What was the AT? See here, dV upon dt, dV upon dt, right? dV upon dt. So when dV upon dt is there, so in the place we can write dV upon dt in dot ds. Achha, now see here, ds upon dt is what? ds upon dt is what? Velocity. ds upon dt is what? Velocity. So d work done net equals to M into V dV. See what we are getting? V dV. right? Acha, now we will draw work done equals to what you are getting mere bhai, work done equals to integration of d work net ठीक equals to, here what will happen, m into initial to final velocity was changing. The initially velocity was v1, finally velocity was v2, right? So here work done equals to what we are getting, m into v square by 2, ranging from where to where, v1 to v2, like this I am writing v1 to v2. So what will happen, v square by 2 minus v2 square by 2 and v1 square by 2. So v2 square by 2 is saying what, kinetic energy final, and v1 square is saying what, kinetic energy initial. So what we can write mere bachcho, what we can write, see, work done, all will be equals to work done net we can write will be equals to change in kinetic energy, which means K final minus K initial, a very important part of whole work energy theorem. We can write like this. So what exactly we got from this theorem? We got that work done by all the forces in a system, because I have taken in one system many forces were acting, work done by all forces on system. I'll write that point, work done, see the point what we have got, work done by on one particle many forces were acting now. So work done by all forces we have taken, work done by all forces in a system, in one system only I was talking, in a system will be always equal to the change in kinetic energy, will be always equal, I'm writing it here, will be always equal to change in kinetic energy. This is the work energy theorem said. Acha, when we talked about the work energy theorem, so a little bit I'll say about the variable forces, work done by variable forces. See here, work done by variable forces. So work done by variable forces means what? Work done by variable forces means what? The force is acting in 3 different conditions. Now work done by variable forces, just see that thing, it will be clear for you. Work done by variable forces, ठीक. So when work done by variable forces is coming, so how the force can change, let's see. If force is there and it is variable, it is variable, so it can change in 3 different ways. 3 different way means what? 3 different way means what? Direction is changing, है ना? What can happen? Magnitude is changing, right? And both magnitude and direction is changing. Magnitude and direction both are changing. both are changing. So now if I will, if we talk about that work done, so like if I have taken that particle A is there and here one particle is there B, and that particle is moving from here to here, some distance S is there as vector. So work done can be written like this. What the work done can be written by? To work done will be, what was the work done? Work done will be equals to integration of f dot ds, but it is ranging from where to where? 0 to s, 0 to s. We can write like this, right? So 0 to s it is changing. Okay, bhai. When it is changing, achha, little bit I'll go for the flashback of kinematics. When we studied kinematics, there we studied about the graph. If you remember, we studied about the graph. So we studied about the graph of AS graph. AS graph we have studied. What we studied in the AS graph, mera bhai? What we studied in the AS graph? AS graph. Okay. Like in AS graph, I have taken any point that a particle has moved from A to, like, point from here velocity was v1 and here velocity I am taking v2. It is at some s1 and here it is at s2, right? So there what we were taking integration. Integration will say about what? Area. Integration will say about what? Area. If you remember, we did this thing, area. So area will be equals to integration of A dot ds, A dot ds, right? We did this thing. Acha, what is the A here now? What is A? We can write A as v dv upon ds dot ds. So ds khatam, ds khatam. So what we did, bhai? V initially was what? v1, finally it was what? v2. So what we have got, mere bhai? What we have got? V square by 2 means v2 square minus v1 square by 2. v2 square minus v1 square by 2. We have got this thing. That same logic we will apply here. Here what more extra thing came? Mass. Here what has came, bhai? Here what has came? Here came mass. Let's see here. Here came mass. What mass came? Everything is same. Directly we can say this thing. See now here. Here what is there? M into A. This is only said as by F net. This is only said as what? F net. Thik bhai? Acha, this is S. Same line I am taking. Same line I am taking, like some curved part. Right? It is having some velocity, initially it is having some velocity v1 here, and here it is having velocity v2, right? That's where it is having, here it is having s1 and here it is having s2, right? Getting my point? So this is the condition. So here also what we will write, mera bhai? Here only one thing will be added. What is that one thing will be added? Mass will be added. Good. Mass will be added, mere bhai. So area will be what here? Area will be what? M into M constant came outside into A ds. We can write M into integration of v dv upon ds dot ds cancel out. So we can write from here directly, see, m v2 square minus v1 square by 2. See, v2 square minus v1 square by 2. What does it saying? This is saying about this is saying about work done. So any graph you are getting, fs graph you are getting, directly you can apply this formula and you can say the answer very easily and very perfectly. It's a very important part. It is saying about work done. It is saying about work done, right? So we got to know about the work done. Achha. Little bit more in this point I will be saying, like when the particle is moving, displacement is taking place by, right? Achha. Now point of application also we have discussed. Work done directly we can find if any graph we have got, final we need, initial we need, and we can get the thing. Now when the person is walking, like I am walking here now, getting my point? I am walking now. So when I am walking, my one leg is down on the floor and another leg is up in the air, right? Let's see this thing. Walking man. We will write it as a walking man. Walking. Just a minute. Walking man. A beautiful concept it is. Thick. And we are moving in a horizontal path. Bhai. We are moving in a horizontal path. Like this is the horizontal path I am making for you. Like this I have made it. Right? Achha. Here if a person is there, how the person will move? How the person will move? One leg will be on the air and one leg will be on the ground. Like this only we will walk, no? Like this only we will walk, right? So now if I will say why normal, how the normal is acting then? How the normal is acting? See, normal is acting from here. This is the point of application of force. Thick. Normal is acting where? Up. Thick. This point, right? I'm just like I'm writing it. This is what? This is what? Point of application of force. Take point of application of force. Acha, mg by mg. Mg is acting like this. Mg. Right? And I am taking no slipping condition. No slipping condition. No slipping condition. No slipping. If no slipping is there, it means it is confirmed that friction is working there. Right? Friction is working there. Achha, which type of friction is working? Achha, which type of friction is working? Which type of friction is working? Static friction is working. And friction is working where? The direction we are moving. Front friction works. So here Fr I am taking, and this is which type of friction, mere bhai? Which type of friction it is? Static friction. It is which type of friction? Static friction. Static friction we are taking. Right? Acha, when it is moving, so I am taking the displacement and all everything. Like S is in this direction. Right? V is in this direction. Right? A naught is also there. Acceleration is also in this direction. A naught. A naught is also in this direction. Okay? No slipping condition have taken. When we have taken no slipping condition, so here if I ask you what is the work done by normal? See here, I am writing these things. Work done by normal, work done by mg, work done by friction. Which friction? Static friction. To work done by normal, we will say, acha, normal work done is where here? Acha, the displacement is where here? Arey, 90 degree. Means work done became what? By normal became what? 0. mg. mg is where mg is acting down, displacement is in this direction. To work done by mg became what? 0. Are you getting my point? Are you getting my point, everyone? Work done by friction. Work done by friction is in this direction. To work done by friction is where? Work done by friction, what happened? See? 0. Means work done by friction, work done by mg, work done by normal became what? 0. So we can write like this, that net work done means work done by normal, work done by mg, work done by friction is equals to K final minus K initial. Now only we studied from the work energy theorem that net work done will be equals to change in kinetic energy. So K final minus K initial will be the net work done. So K final minus K initial, K final minus K initial, right? Acha. Acha, one more work is there, muscular work. We can say it as a muscular work. M work done by muscle work, right? Or internal work done also we can say. Work done by muscle, work done internal. So now if you see, particle started from rest, means initially velocity is what? 0. So initially kinetic energy became what? 0. So here initially kinetic energy became what, mera bhai? 0. Initial kinetic energy became what? 0. But finally it is having some velocity. So what is the velocity, mera bhai? What is the velocity? Half m v square. So work done by muscle, what you have got here? Work done by muscle, what you are getting here? Half m v square. It's a beautiful concept. When it is happening? When the particle is moving in the no slipping condition, when the particle is moving in the no slipping condition and it is having velocity, it is having a acceleration and displacement is front. So muscle velocity, work done by muscle, what happened here? Half m v square. Acha, horizontal to we have seen. Horizontal we have seen by. Acha. Now when like rope is there, like army and all are there, no? They are climbing on the rope, or monkey is climbing on the rope. So how rope, it is moving in a vertical point, sorry, in a vertical point it is moving. So we'll see that vertical point also. See here, vertical point also we will see. Like vertical thick. Okay, so like if I wait, I'll take it that line also from here till here. Thick, like person, one boy is there, boy is holding a rope and it is climbing up. When it is climbing up, let's see here, like it is climbing up, it is holding with 2 hands, right? So initially it is having some velocity 0 and it reached here, like I am taking it here, it reached here. So here also velocity became what? 0. Here also velocity is becoming what? 0. It is climbing up now. Thick. When it is climbing up, if we see very properly, like I am drawing one more diagram for this thing. Like when it is climbing up, so just a minute. Here that boy was there, it was holding, right? Achha, now if we see very properly, he is applying force like this, so tension is acting, and tension and friction is also acting, no? To tension and friction, if I will talk here, to tension and friction is acting where? Up. है ना भाई? Tension is equal to friction, we can say, friction between them, Fr. Thick, tension and friction is working like this. So work done by friction will be there, work done by tension will be there, something, we will see that thing. Achha, mg is acting where? Mg is acting down, like h height I have taken, from here to here, h height I have taken, right? H height we have taken. So work done, if we see here very properly, work done by friction is equal to work done by tension will become what? 0. वर्क डन बाय टेंशन वर्क डन बाय फ्रिक्शन बिकेम व्हाट 0 है ना भाई ठीक. बट वर्क डन बाय mg इज आल्सो देयर भाई. वर्क डन बाय mg इज देयर. अच्छा mg इज एक्टिंग वेयर डाउन, बॉडी इज मूविंग वेयर अप, तो माइनस ऑफ mgh, माइनस ऑफ mgh ठीक. तो नाउ इफ आई विल अगेन राइट दिस थिंग like this, that work done by mg plus work done by friction ठीक plus work done by muscle k final minus k initial. It is having initial velocity is also 0, final velocity is also 0, so kinetic energy became 0 here. Kinetic energy became 0. Work done by friction is also 0. So work done by mg is what we have got, minus of mgh is it plus. So I have sent it that side. So what you have got, see my m work done by muscle, work done by muscle. So negative minus sign will be erased. Yes, erased, right. So this the value we have got here. So what are the things we have seen here today? We have studied about the work, we have studied about the force, we have studied about the displacement, variable forces, we have studied when the particle work about the work energy theorem, which says that all the work done you add and make it equal to net change in kinetic energy. Then we have seen in the vertical point also, then we have seen in the horizontal point also. Take. So next class we will proceed some more thing and some more good things will be coming. Thank you.